Hello, everybody. Welcome. Thank you for joining us. My name is Ramon Burgos. I am the HV sales manager for HV Technologies. We will be starting just now. Again, I want to thank you for joining us. Today, we will be going through a few slides to give, with the intention to give a basic introduction to Haefely's distribution transformer test system. Nothing too technical, but enough so that you can get a good feeling of what the system is, what it offers, and how it could possibly be integrated into your test regimens. So for this presentation, like I said, we'll talk a little bit about the importance of transformer testing, the types of transformer tests that are industry standard. And then we'll go into the DTTS and its testing capabilities and some of its components and how it could be configured. And then we'll have some time, as always, in the end to accept some questions. If you have any questions, you could always write them in the chat box, or you can wait till the end of the presentation and we can unmute the microphones for live questions. So basically, when transformers, at least distribution transformers, are, like I would say, the workhorse. They have they're usually at the far end of the transmission of energy. So it's basically, we're talking about transformers that are placed, pad mount transformer, pole mount. Sometimes we have other types of transformers. These are responsible for getting power to customers. So why do we want to test these types of transformer, or any transformer for that matter? Well, from the customer standpoint, and also from a manufacturing viewpoint, transformer testing is important because transformers usually are an expensive asset. Usually, customers will spend a lot of money to acquire transformers, and manufacturers also want to make sure that they comply with all the loss information and comply with the designs and the requirements of the customer. So as far as total cost of ownership for the customer, you have the cost of your transformer, which is your design and manufacture of the transformer that goes into that. And then you have your costs associated with losses, and losses are inevitable when we talk about transformers. We have losses caused by the iron core, which are continuous. We have losses caused by the copper losses, which depend on the loading conditions. And then we also have losses that are present, stray losses that are present due to the just inherent to the transformer design. So it's most of it is required for manufacturers to report these losses so that the customer is aware of how the transformer is designed and what they should expect when they are investing in transformers. From a manufacturing standpoint, it allows manufacturers to ensure the quality of their designs, to keep those losses low and to make sure that they can keep voltages stable. And also they can test the testing of transformers will allow you to avoid or detect dielectric failures in the field or at the factory. And finally, as far as compliance, nowadays we have this new, it's not new, but it's a requirement across the board for energy efficiency and initiatives, where now there are regulations that are having manufacturers meet or exceed certain efficiency levels. For example, the U.S. Department of Energy in 2027 is proposing a new set of standards. So it's important that transformer manufacturers can meet those standards or exceed them, and in order to stay active in the market. So when we talk about transformer test, there's a industry um, standard or consensus where there are three types of main testing. So you have your routine test, which is for mainly confirming the operational performance of each transformer in a production lot. So routine tests are carried out on every unit manufactured. So these are tests that right as the transformer is coming off of the production line will be put through this battery of routine tests. Then you also have your type or design tests, and these are usually conducted on a transformer which is representative of other transformers to demonstrate that they comply with specified requirements that are usually maybe not covered by a routine test. So in a lot of transformers to test the design, you'll pick one, run the test, and each transformer in that lot should have that basic characteristic. And then there's also a group of special tests. These are other than type test or design test or routine test that sometimes the manufacturer agrees to do alongside with the purchaser. They will have whether it's impulse testing or zero sequence impedance or sound level. It's just another battery of tests that can be agreed upon with the manufacturer or even solicited from the manufacturer. So as far as the DTTS, we have the advantage that the DTTS is basically one solution, one turnkey solution for all routine testing. You'll be able to do testing like winding resistance to verify continuity between the windings. You'll be able to do turns ratio to verify your voltage ratios and phase displacements. You'll also be able to do insulation resistance measurements to determine the insulation resistance from winding to earth or between windings, and that'll help you gauge the condition of the transformer. You also, with the DTTS, will be able to do your applied voltage testing, which verifies the integrity of the main insulation. And then you also be able to do induced voltage testing. And induced voltage testing verifies your line terminals and the windings interturn and phase and between phases. So you have your applied, which will do your main insulation between your windings, your induced, and then you also have the capability to conduct your no load loss, which is the loss developed by the excitation of the transformer. And this is where it represents a considerable amount of the energy during the lifetime of the transformer. This is due to the iron, to the core losses. So these are always present within the transformer. So with the DTTS, you'll be able to test your no load losses and verify that it is in line with what the manufacturer is claiming. Finally, you could also do your load loss test. So this will give you the exact knowledge of the load loss of not only for your capitalization of losses, but it's also important to know for your safe operation. So this is due to the current, the copper losses due to the current or the loading of the transformer. Uh, Also, you as options, you can also do a heat rise, which will guarantee your temperature rises for your oil and your windings, and even do partial discharge testing. So partial discharge testing on your transformer will help you localize areas within the transformer that are exposed to elevated dielectric stresses. So all of these tests can be done with the DTTS. And here's just a quick summary. You'll be able to do all your routine testing, and at the same and it all goes to a centralized control software. So all these tests will be able to be run with one system. It's a compact system, and it conforms to the applicable North American standards, which are the IEEE C57.12.90 and C57.12.91. So you have a complete distribution transformer testing solution in a very small footprint. So when we talk about distribution transformer and the DTTS, we're talking about transformers that on the high side can be anywhere between 6 to 36 kV on your high side, and on your low side anywhere between 0.11 or to 2.4 kV. So this basically covers what is the industry standard for medium voltage distribution transformers, up in the low side up to 2.4 kV. If we have noticed in North America that there are low voltages that can exceed 2.4 kV, but we can also provide a solution for those cases as well. So it's not there are things we can do, which I'll show in a slide in the coming up, where we can integrate other equipment to get to higher voltages on your low side. So basically, the DTTS is divided into three main models. So we'll have the DTTS, the 3-500 to 500 kVA, up to 500 kVA. Then we have the DTTS 3-2500, which is 2500 kVA, and your DTTS 3-5000, which is the 5000 kVA unit. So we have up to 5 MVA, if the testing capabilities, up to 10 MVA with the DTTS 5000 if you don't require heat run. So it will cover a wide range of transformer capacities. So like I've already mentioned, some of the DTTS will do all your routing tests within one unique system. It's a very simple as far as installation and readiness to use. It's sort of like a plug and play type solution, and it's really compact compared to other transformer testing systems. As far as being a turnkey system, this is everything that you'll see in this presentation as far as components are supplied by Haefely. As a unique supplier. So they will cover every component in the DTTS. So you don't have to be so it's a lot easier if you need any support as far as troubleshooting or support for spare parts and stuff things like that. You only have to turn to one supplier. With the DTTS, you will achieve higher testing throughput. You will be able to test more transformers in less time because of the way the modular way it is set up, and we'll get to some slides where you'll see how we can configure and how that works. You also have the application software, which basically centralizes and controls and the reporting. So everything communicates to your application software, and that application software is used to basically run the DTTS system. And then the DTTS system is unique in that it utilizes a frequency converter instead of the typical, or let's say the older technologies of motor generation. So with this frequency converter, Haefely has been able to add a set of a series of filters and other control technologies that will give you the advantage of being able to control wave shape and being able to have voltage control, uh, uh, real-time voltage control, real-time symmetry control, and real-time THD control. So basically, while this for a loss measuring system, you'll be able, which is, when you're measuring loss, the voltage wave or wave shape is very important, that is stable. So you have accurate results or accurate measurements. So with this control, with this real-time feedback control, we can, the system is dynamically um, ensuring that the wave shape of that is being produced is of the highest quality, so to achieve highest accuracy. That we will see here in these block diagrams. In the following two slides, we have block diagrams where I'll demonstrate, for example, in a DTTS 3-2500, you'll have your connection from your power grid, and that will feed into the frequency converter, which has pulse width modulation controls. It has a sinus filter. Then the output of the frequency converter will go into a low voltage filter. We have a low voltage capacitor bank for compensation, and then a step up transformer to achieve your output voltage. And then that step up transformer goes through a set of CTs and PTs for your transformer loss measuring system. So all of this in this box is contained within this 10-foot container. So basically, everything you need to run your loss test and others, you will have all in one container. With the DTTS 3-2500, you can do up to 2500 kVA with heat run, or up to 5000 kVA without heat run. So you have a wide range with the 2500. In this slide, the example is for a DTTS 35000. So DTTS 35000 is basically a 2500 kVA unit, and then on top, you stack on top an automatic capacitive compensation container. So these two containers work in conjunction, and it'll give you the capability to run test up to 5000 kVA with heat run, or up to 10 MVA without heat run. And 10 MVA, depending obviously on all the analysis of transformer data, but that's basically where Haefely has been able to confidently say that they can reach up to 10 MVA without heat run. All again with a small footprint. This container stacked on top, it won't take up an additional floor space. And then finally, this is an example of a DTTS 5000. And then for voltage outputs higher than 2.4 kV, we can provide a step-up transformer. So basically, you will have your input goes through the same DTTS container with the frequency converter and the step-up transformer. And then from step-up transformer, you would feed to your intermediate step-up transformer for your higher induced voltages. And then you have a series of filters, and then it'll go right to your test object. And in this example, it also shows on this side the coupling capacitors and PD partial discharge detector, which can also be an option in your testing regimen. So just a few. Just to show the modularity and the potential for expansion of the DTTS system. So when you order, or when you come to think about acquiring a DTTS system, these are just the main components that will be supplied by Haefely. So the following component, you'll have, like we said, the frequency converter, you'll have a capacitor bank, the loss measuring system, all your PLC control, and your step up transformer all in one container, and just which is like I said, it's a 10-foot container, and basically you have an input voltage of 380 volts up to 500 volts, 50 or 60 hertz, obviously 60 hertz, three phases. So that's your main power test bay. And then for example, with the DTTS 3-5000, you just have that additional high voltage compensation bank on top. So here's a look into what the frequency converter, the various controls. So in the front, on one side of your DTTS, you will have, as you'll see here, the frequency converter, all the controls, the PLC. Then you'll have your capacitor bank, and over here, this is the watt meter for your loss measurements. So this is all placed in the interior of the container on one side. On the other side of the container, you will have your step-up transformer with taps. And so everything is wired, interconnected from factory. So really all you have to worry about is the connections, your input and output connections. Everything else is done within the container. So like I mentioned, we have the low voltage capacitor bank. It's a 375 kVAR at 60 hertz. So basically it's four compensating capacitor banks. There be and they are connected under no load conditions into the circuit when performing load loss and heat run testing. These capacitors are used to compensate the inductive load of the transformer during load test. So the compensating capacitor is switchable in 4 steps and is remote controlled by the DTTS software. Like I said, this is fed from the 400 volt side of the transformer, of the power cubicle of the high voltage step up transformers. So, you also have the transformer measuring system, the TMS 650-4-500, which is a 4 kV 500 amp, basically a loss measuring system. It's your CTs and your PTs necessary to and your watt meter in order to measure your losses during your load loss measurement test and your no load loss. And as you can see here, we actually have two different watt meters that can be offered with the standard WT330, which is from, we can achieve the following accuracies. So we have very high accuracy. For example, at a power factor of 0.05, we can achieve almost 4. We have 4.2 at a cosine, at a power factor of 1. It's 0.2%. So it's a highly accurate and very precise loss measuring system. So as part of as far as applied voltage test, so we can offer as an option, if you're interested in applied voltage testing, the ACA dielectric test set, which is basically a 100 kV, 40 kVA test single phase transformer. And this is apart from the container, and then but it will interface with the controls. It will be controlled by the DTTS software. Also, optional, but can be easily integrated with the DTTS are components for partial discharge. We can supply, your coupling capacitors and high voltage filters for each winding, with a PD detector and PD calibrator, again, that you can optionally have integrated into the DTTS and also will feed into the application software. Fine, and also we have the optional low power test bay. So with the low power test bay, this is where you'll have your turns ratio and winding resistance with DMAG and your installation resistance measurements. So this is a mobile unit that's apart from the container. It comes with its own laptop that does connect to the DTTS software. And this is where you will run, you'll have your capabilities and for turns ratio and winding resistance, and also for installation resistance. If for those who are familiar with Haefely's 2293, basically that's what we have inside this low power test bay. So if you're familiar, you know that the 2293 is a one-time connection setup. So basically you connect, your high voltage leads and your low voltage leads, and you can run both tests without having to do any changes in connections. Finally, we have what I've been mentioning about the main control unit, the application software. So this uh, the application software will be integrates all your routine tests, your no load loss tests, your load loss tests, induced and applied voltage test will be all integrated. And like I said, optionally you can have all the other tests if you choose to have winding resistance. Those two can be set up. And basically, the control unit provides the output and current voltage, the output voltage and current according to the test requirements that are entered. It's charged with controlling the switching of all the test circuits. It'll give you your active system configurations, the status of your configuration. It'll provide alarms and display your values of current and voltage and power. Also, it has the capabilities. It provides emergency switching off and interlock capabilities. It'll partly do automatic calculations and setup of test parameters. It can generate step-by-step guides. You can do recording and storage of measurements and test data. And then you can also generate your test report all with one application software. So like I've been mentioning, we're talking about a one turnkey solution for distribution transformers. In the next slide, we're going to talk about, we talked about reducing testing times. And when we talk about the DTTS and how we can configure it, so we can configure the DTTS with one, two, or three bays, depending on obviously your testing requirements. So for example, with the two test bay configuration, you can be running on one transformer your induced and your no load and load loss tests with partial discharge on one transformer, and at the same time on another you can run your low power test on another transformer, and then you swap them out. So you're basically with a two bay configuration, testing cycles can be anywhere between 10 to 15 minutes, obviously depending on the transformer design and how many taps it has. But you have this capability of being able to test multiple transformers at the same time and kind of speed up the time, so you have less backup as far as pending testing. Also, the DTTS can also be provided as a three bay configuration. And in a three bay configuration, we take out the applied voltage test. If you notice here, applied voltage test was part of the first bay. And then with a three bay solution, what we can offer is to remove the applied voltage test bay, put it separately, so that now you can do on one transformer your induced no load and load loss, on one transformer your applied voltage, and on another your low power test, and then swap between them, and that could considerably lower your testing times. Haefely's been able to. They say that obviously depending on the transformer design, number of taps and whatnot, you could reduce testing cycles to anywhere between 7 to 10 minutes if using it as a three bay. So there's a lot of uh, configurability, and it's just there's many options from as far as testing for and kind of speeding up tests and making sure that obviously with the high accuracy of the system, um, that is guaranteed as a whole system, because since it's enclosed in this we can say that the accuracy of the entire system is guaranteed. So, and this slide, I just wanted to give you a feel for what a DTTS uh, testing system may look like in your test bay. So as you can see here, this is a DTTS 35000, 3-5000. So this one will have, as you can tell, it's a very small footprint. We have containers stacked on top. So basically, this system is taking up the more or less, maybe a little bit more of the footprint of this transformer on this side. So it's not taking up much floor space. It goes up rather than to the sides. And then this is a good picture of the low power test bay. In the background, you can see the applied voltage transformer. So all of this is, will be it will be the most effective solution, but it'll also be the most compact and for your space. So, again, the frequency converter, we have highest accuracy, and it's completely calibrated and certified from the factory. We have very low system noise as far as partial discharge. So partial discharge measurements are highly sensitive. And then, with the software and the way the software integrates all of the different testing routines, you basically have the capability to test get many tests done on many transformers, and basically have this whole system can be operated with just one operator, basically, in most cases. So I'm going to basically, so this is what what is the presentation.